Okay. Um, what I was talking about, IP address about uh, space sizing of IP disk space. For example, if you need uh, 16 IP address, but you plan uh, 500 IP address. In that case, there will be some unused IP address. Unused IP address is vast of IP resources. At the same time, it is security threat. It is recommended that you will not uh, assign some addresses and leave some unassigned addresses in a subnetwork that can be used or misused by some malicious actors. And that is why we have to plan IP addresses carefully, and you have to maintain an inventory in your real life activity. Okay, it is important. In some organization, people are not properly maintaining the inventory. Sometimes IP address conflict occurs, and some people confuse which IP to configure to which computer. Okay. So in this planning, we have to use classless IP address. What is classless IP addressing? Classless means in at the beginning of the development of networking, classful IP address was developed because there was no classless configuration of IP addresses. For example, for class A, we have 10 dot something IP addresses, and subnet mask was just 255.0.0.0. It was fixed, and for class B, we have 255.255.0.0 subnet mask, and class C 255.255.25.0. It was the subnet mask, and these are fixed, and it was responsible for wasting IP addresses. For example, you may use class A IP addresses, and you assigned 10 IP addresses in your organization. Maybe you are wasting millions of IP addresses. So it was not efficient way. That is why subnetting a classless IP address was developed. In classless, you can use subnet mask as per your requirement, regardless of considering class A, class B, or class C. That is why it is called classless. And another concept is variable length subnet mask. VLSM is also associated with this idea. Variable length means actually if you consider class full IP addressing, your subnet mask is for class A /8 or 255.0.0.0. For class B /16, class C /24. But in classless or variable length subnet mask, these are not fixed. They are not just multiple of 8. They can be somewhere between 8 and 32. Okay, our total length of IP address is 32 bit. So from 8 bit to 32, we can use anywhere. For example, it can be 22, it can be 30, 28, 29, even 30, even 31. That is a special case. I will also discuss. And minimize worst of IP address as much as possible. So these are done to ensure to minimize IP address worst. So how we plan in real life? For example, in this example, okay.
Yes, sir. How does classless IP addressing differ from variable and subnet masks?
Subnet mask related? Sorry.
I said that how does classless IP addressing differ from variable and subnet masks? What is the difference between the two?
Okay.
In terms of wasting IP address.
Okay. Okay. Let me put, can I share the whiteboard? I don't know. Right. Okay, I'm showing with this. Okay, we can proceed with this block. Okay, already. Okay, before going to whiteboard, look at this IP 172.23.28.0/22. It is IP address. That means in this first 22 bit is fixed for networking. Okay. It is okay. First 20. Look at this. Just first 22 bit is.
So your screen is not showing.
Oh, sorry. Look at this IP block 172.23.28.0/22. Means first 22 bit is fixed for network part. Okay. First 22 bit is fixed for network, and remaining 10 bit is for host. Okay. If we talk about the 10 bit for host, that means 2 to the power 10. Okay, number of hosts. Then is okay. Let me use the calculator for this. That will be. Okay, let me do a scientific calculator. Or can you okay? I can. Square.
It's 250.
I need it scientific. I need a scientific calculator. Do you have? Oh, maybe. Oh, maybe it will work. Okay, got it. 10. Okay, how many? 1024. Okay, that is with if we use this IP address, this network address to assign what will be the IP addresses. Okay, let's go to the whiteboard. One seven. Can you see the whiteboard?
Yes, sir.
23. It is difficult to write here actually. I don't have actually some devices that is here. Okay, 24.0/22. What I was talking about. If you use how many IP addresses, you will get once IP address range will be 23.28. What will be the first IP address? First IP address will be 1. Okay. And it will continue with IP address 172.23.28. Actually, it will not be like no, it will. Okay, let's check. No, not 28 last week. Actually, maybe it's 29, 23 and 29. 29. Then it will be 255. But 255 will be the broadcast address that will not be able to use usable IP address, something like this. Okay, around 1,200, 1,024 minus 2, that is 122 IP addresses will be available for use. And you have a network which has 10 hosts. So you are using more than 1,000 IP addresses or allocated 10,000, 1,000 IP addresses. In practice, you are using only 10 IP addresses. You are wasting 990 IP addresses. Okay, this is the case of wastage. Now, how can we stop this wastage? Okay, let's look at this.
Sir. Hello, sir.
Yes.
Yes, sir. In this IP address, you see that the best range in the whiteboard. Can you go back to the whiteboard? The whiteboard that you have just shown.
Okay, let me show you. Okay, you can
Yes,
see.
sir. The first IP address is 172.2.23.28.1.
Yes.
And the last one is 172.23.28.29.254. So my question here is that the first address, our third octet is not full because we can get the last IP address with .23.29. So why do we not consider .29 as the first address? Like we can say .29.0 as our first IP address. Why do we always consider .28?
No, we are not always consider the initial block will be planned considering high level requirement. For example, the whole organization's IP address requirement. Okay. In that case, for example, in your organization, you need around 1,000 IP addresses. Then you will take this kind of block. Maybe you are required to consider other offices or other networks for different reasons. So that is why you have chosen this IP block. Okay. Then you will subdivide, which is the subnetting. Through subnetting, you will segregate or divide them and use in a smaller, making them a smaller network. That is the way of. In practice, we are not using this type of block in most cases. Moreover, if you use longer or large IP block, it will not be efficient for broadcast issue or other issues or troubleshooting issues. That is why it is recommended to use smaller block as much as possible. For example, /24 are in which around 255 IP addresses are there, which can be used in medium-sized network. But we can take smaller /28, /29, even /30. For example, if you assigned IP address between two routers, point-to-point network. Point-to-point network requires only 2 IP addresses. So in that case, if you use IP address range of this block, that will be inefficient and it will not make sense. That is why we will divide them. That is the aim of this lab or this practical. That is our main aim. If you calculate everything, it will be clear. For example, for finance department, okay, you need 9 IP addresses right now, and do not consider future because future can be anything. But in real life, you can consider this. For example, you have 9. Ask your management team or planners, high-level planners of the organization, how many users or computers will be added to your finance team. They will ask, okay, we have planned to add 10 more. Okay, then you will consider with 19. That is, you are prepared for near future, and you don't need to plan again in the near future. That will be difficult for you. You will just assign those IP addresses to 9 devices and keep inventory that you have some reserve IP addresses for this block that can be used when those 10 computers are added. Okay, but in this exercise, you just use as it is mentioned here. Okay, finance team has 9. Okay, how can you take your IP block? You will take it nearest 2 to the or n power. For example, which will be in terms of binary. What will you? If it is 8, if it was 8, then you could use to the power 3. Okay. that is 8. But if you calculate to the 4, what is 16? That is, it will be you will, but oh, it is you will use. Let me take what document that where I can write. Okay, here we can write 16. 16 means 2 to the power 4. Okay, that is for host we will use 4-bit. Okay, 4-bit for host. Okay, I'm just completing one.
So we are not seeing.
Oh, what is it? I'm sharing a screen actually. Can you see?
We only see the whiteboard.
Oh, screens. Okay, let me. But I can see screen is sharing. So what? Okay. Can you see the Word document?
No, sir.
Stop share. Now nothing is shared, right?
Yes, sir.
Just sharing again. Maybe some malfunction. Screen is shared. Can you see? Please confirm.
Scan.
Okay. It is 4-bit. Okay. 4-bit for host. Then what are the remaining remaining bits per network? If you 32 minus what I use 32 minus. Can you see the screen?
No, sir.
What's wrong? Strange issue. Maybe something wrong. Okay, another way. Just sharing a word. Still not showing the
No, sir.
picture?
It's not sharing.
Your network is a bit slow, I guess. That is why it's taking some time.
But everybody is facing the same problem. But I am seeing here that the screen is sharing.
It's loaded.
Oh, it is.
Sir, it's stuck, so you can stop and share again.
I stopped actually several times. I stopped. Now maybe it is hanging some problem. Whiteboard again. Can you see the screen there now?
Yeah, we can see that.
Okay. Maybe some software malfunction. Okay. What we what document here? Okay. What I was talking about that for first item, finance team has 9 computers. You have to plan IP address for this team. How many IP address required? 16. Actually, effective IP address will be less than 2, less 2. That means 16 minus 2. Because 2 IP addresses, first one will be used for subnet and last one will be used for broadcast. That is, you can use only 14, and out of them you have to use one for gateway. That is 13 for actually host in practice. Okay, that is we are getting only 4 IP addresses in excess of our requirement. Okay. Now, what is 16? 16 is actually to the 4th power. Okay. 4th power. Why we choose 4th? Because if we choose 3, it will be less than 9. That is, it is not possible to use. So we use nearest round figure. And this 4 is host bits. Okay, that is, we have 4 bits for host, and the remaining 28 bit. Okay, 28 bit for network. Plus 28. Okay. CIDR, classless interdomain route. That is, sometimes subnet mask is written in terms of number of network bits. Are you clear about this? This is very important. If you work in networking or IT related issues, then you have to work with this every day. Nobody is saying.
Yes, sir.
Diko, clear. It's clear to you. Okay.
Yes, sir.
Yes, sir.
Okay. What is plus 28? We can also write in decimal format. 255.25. You will complete the remaining part. I just giving you an example. Okay. What will be plus 28? What is the IP address?
Is it 252?
No, not 252. Maybe 248.
Yes.
Okay, 240. Let me. How you can easily get it? 256 minus 16. What is? Okay, no, 240. 240, right? 240.
Yeah.
Okay. Okay. Now, what will be the network address? Let's look at network address is this. Just this one. Because first it is given to you. Okay. Then what will be the first IP address? 172.23.28.1. What is the last assignable IP address? 23.28.2 654.
That's 29, sir.
Huh? No. We are not using the whole range. Maybe here you are a bit unclear. No. Sorry. What? Sorry. I also made mistake. Okay. We will use only. Sorry. 16. 16. It will 15. What will be the broadcast address? Okay, sorry. What will be the next? We will cover 16 IP addresses here. Okay, that is 0 to 60. Is the next?
Sir, I have one question.
Okay, ask. Okay, ask.
Hello, sir.
Yes,
Sir,
continue.
how can you write the assignable IP address range in the 14, that 172.23.28.14? How can I write it?
Okay, let me go.
Only, sir, 14. How can I get to this 14?
Okay, I understand your question. Okay, our block is 16, right?
Yes,
Our
sir.
block is such a block size. I'm writing block size equal to 16. Okay. Then assign number of assignable IP equal to 16 minus 2, just 14. Okay.
Okay,
Just
sir.
14. Okay, just 14. That means your first IP is 1 here. Because our network is 0. Network last octet of network is 0. Okay. I'm right.
Okay, sir.
Okay, for explaining further.
Then, sir, our first IP address will
That means
we
our
start from 1 and last will be 14.
Okay, it is 1 and then it is 1 to 14. Okay, what about 15? 15 is broadcast. What about 16? 16 is another network. 16 is network. 16.
Okay, sir.
Okay. Next IP address. Okay. Here we will continue with another one. For 22, can anyone tell me what will be the block size?
Sir, 32.
Okay, it is not possible.
5 bit for host.
32. Okay, 5 bit. Okay, great. 5 bit for host. Okay. And then okay. Then what about our network?
/19.
Huh?
No,
27.
/20.
27.
7. What is in decimal? Tell me the decimal.
224.
254. 2 to 4.
Yes.
This.
Sir, 2 to 4.
Okay, great. Now tell me. Oh, sorry. I am writing something wrong. Broadcast IP address. It is fast IP address. Sorry. I will change the file again. Okay. After finishing this. Okay. Fast IP address. Broadcast address. There should be one column. Broadcast. Okay. I will tell me the fast IP address.
172.23.28.
What will be the first IP address?
.1.
Sorry? Sorry?
Sir, 17.
That should be dot.
Right, 17. Nazneen is correct.
So there will be IP conflict. IP address conflict.
Why IP address conflict?
Because we might not know the next subnet after we have done the first subnet. This is just we are assuming now, but if we are subnetting, we might not know the next subnet. So it should be okay, sir.
No, we are, for example, for past one finance state, we have IP address 1 to 14. It is it has subnet mask is 28. If you put subnet mask 28, and you will not be able to assign 17 or any other
Yes, sir.
any IP, because that will be the out of the range. What mask does? Why we use mask?
Identify the
Mask.
network.
Mask just identify your network portion and also specify the host portion, because host portion will be if we run the end operation, for example, because network part is all one, right? And host portion is all
Yes, sir.
zero. All zero. If you understand the binary, it's very easy for you, I know. Okay. Then what will be the last IP address?
Sir, 15. 172.23.28.
Okay, last octet is enough for me. 17 is first one. What will be the last IP address? Nazneen, talk. Can you repeat? Or anyone else?
30.
30.
Sir, 32 minus 2.
Yes, it is. That is the number of hosts. You are talking about number of hosts, but
So we should
no.
substitute.
My table is something problematic. Sorry, it is last IP, last IP, last. You are right.
So it should be 14 plus 14.
No,
14
it
times
is. It would be
14 plus 16.
16 plus
14
32. For your block size.
is 16.
How can you get it? Let me calculate 16 plus 32. What is 48? 48. But
Yes, sir.
48 cannot be used. So what we have to 48 will be a next
46.
network. Okay, 48 will be next network. Let me write. So it will be next network. You cannot use. Then what about 40? What happens to or 48? 48 cannot be used.
46.
Just 47. Can you use 47? No, 47 is brought down.
Right.
Okay, that is you use 46. Okay, in this way you will get all the networks. Okay, let's try HR. It is interesting. Okay. Just any other else can tell it. Aminata. Can you hear? Faisal? Usman? Are you not listening, just connected? I am a bit confused. What about Yahya? Yahya and Usnata.
Yes, sir.
Can you tell me the IP block size for HR here? Can you see? What about Ali Atik? Sorry, we cannot see the whole name, however.
Should be 4. 2 to the power of 4. 2 to the power of 2 would be 4.
What will be the value?
2 to the power of 2.
2-bit for the host.
2-bit for host. No, you are wrong.
2 to the power of 2. Our block size will
2 to the power 2
be 4.
will be 4. Yeah.
Yes, our subnet max will be 252.
2 to the power, repeat again. It is very important.
2 to the power of 2 because we only have 4 devices. So 4 devices we will use the block size of 4. That is
No, no. Can anybody else can say before?
Yes, sir. So 3 bits, so 2 to the power 3. So
You are right. Exactly. You are right. What
but there
Nazim,
is no 2 to the power of 3, sir.
said was wrong because you didn't consider one thing. Look, we have to subtract 2.
Exactly.
If we use 2 to the power 2, then we will have 4 minus 2, then we will get 2. But you have 4 devices. How can you assign 4 IP addresses? Okay.
Then we should resolve
When you here will be 8, you know, 3-bit for
Host.
bit for host. You will see in the exam, different type of exam, you will get some figure like 8, 4, 16. But this figure, apparently, some people just transfer to the exponent, convert to exponential form easily. But here is the trick. Because you have to reduce by 2, that is the issue. Okay, just remember it. Okay, in that case, what will be the number of CID and length?
29.
29, 30. Okay, 29, right? 29. For 29, what will be the subnet mask?
48.
2, 4. Sorry,
48.
so 48.
Yes, sir.
48. Okay, just 256 minus 8. We can just calculate without considering binary. Okay. Or for exam or any other test, you can remember some binary exponent which can be helpful. In that case, you can use or answer without any calculator. Okay. Then what will be the first IP address?
Sir, 49. 20.
Right. Right. 49. Then tell the last IP address.
Sir, 52.
No, 52.
So this makes me very confusing.
No. There are two things. Look, with 2 to the power look, 2 to the power 3. I was talking about 2 to the power 3. That means 8, right?
Yes, sir.
8 means what is the number of assignable address? What will be the assignable address? Number of assignable address. Just 8 minus 2, 6.
Yes.
Do not confuse with other things. For example, you are just adding a 48 plus 8. What will be the value?
Sir, what you say, 48 plus?
8. 40. Why 48? 48 is network. Okay.
Yes,
48
sir.
is network. You just add 8. That means you will get 56.
Yes, sir.
Then 56. 56 is another network actually.
Yes, sir. 56 is another.
It is network next address. Just writing 56. So minus 1 is 55. 55 is broadcast.
Yes.
Okay. That is 54.
54. Okay, sir.
Oh, sorry. 23, 28. That is 53. 55, 54, sorry, 54. Just okay. In this way, we will complete the whole table.
So still we are wasting some addresses.
Sorry.
Still we are wasting some addresses.
Yes, yeah, you're right. Yes, still we are wasting 2 for this HF. But it is okay. It is a mathematical constraint. You have nothing to do to reduce this wastage.
What about if we use VLSM, variable length of network?
It is variable length. It is variable length. Look, why it is VLSM? For fast network, you use /28, for second 27, for third 29, depending on our requirement. That is why it is variable length.
So is this not a classless inter-domain routing?
Classless. Of course,
Yeah.
it is classless because we are not using. Look, this 172.23.28.0, which class it belongs to?
It belongs
Tell
to
me.
non-class because we are using classless
No,
inter-domain.
normal.
Usually
just,
it belongs to class B.
Class B, right?
Yes.
Then if it is class B, then what should be the
255.255.0.
255.0.0.
255.0.0.
Yes, but we use a different subnet mask. So it is classless. It is classless. It is variable length and type. Just
So classless and variable length, if I understand, is all the same, right?
yeah, almost same. Yes, same. Or there may be some differences in some senses, but in effect it is same. Okay. If you can understand this table or this scenario I presented to you, it will be enough for you to assign IP addressing in your real life. Okay. In your professional life, you will be asked to plan this type of activities sometimes. Okay. So you have to understand it and maintain moreover, you have to maintain inventory of IP addresses, which is very maybe you have thousands of devices, even millions. For example, if you can think about large organizations, for example, Google, for example, they have so many applications, so many servers, so many networks. So of course, they deploy some automated system. However, in medium organization or other organization, there are some automation, and for this IP address planning and inventory, there are some applications to do this. Otherwise, there will be big mess, and you will not know which IP to be assigned to a device, a new device, or what should be the IP address of a specific device. So it is very important. So although in general sense, it's a simple thing, but in real life, it is actually a difficult and very important task to keep IP address tracking and maintaining inventory. Okay. Okay, complete it. Okay, I am sending this workbook to you again, PDF. Let me close this PDF. I'm sharing you. In fact, we'll discuss about IP address in our later sessions also. Actually, there are so many issues related to IP addressing. Okay, next we will show some routing issues. Please copy it or download it and preserve. Okay, I shared this in the chat box. Okay, very quickly we'll complete interesting topics. Static routing. Okay. Can you see another lab PDF?
Yes, sir.
Adwan? Yeah, thank you. Okay, we will work with two concepts: static routing, default routing, and another issue is how can we configure if we have two connections from two ISPs. That will be our last today's last lab. For example, you have a network. It may be home network. It may be your office, which is an organization. It's medium size, for example, or a small or medium size organization. Okay. For large organization, there are more complex networking that we cover later. But in the beginning, we'll show how this is done. At first, consider an Isp router. Okay. Can you see it clearly, the figure?
Yes, sir, we can.
Okay. Look at this. This is Isp router. It is 2911 model, for example. And user's router, it is, for example, user organization's router. It is ISR 4331. It is connected with a link. Okay, a single link. in most home network or a small organization, and people just take one link or connection for internet connectivity. Sometimes it is disrupted, but they tolerate it because they think that it's okay to experience some downtime. But in very critical organization or higher internet connectivity is very important, that they more than one, at least two connectivity is preferred. Okay. Otherwise, as you will sometimes go offline. Okay. Now we have one internet connectivity. What we will do, we'll if we want to connect certain networks, we will use static route. You know that there are two types of routing: static routing, which is manual configuration. There are dynamic routing, that is, we use some algorithms that can use automatically find the best routing path. Okay, we will cover that in our later sessions. And now a static routing. Okay, what is a static routing? We will just manually configure this. Let me show one here configuration also. I'm just showing one, and another configuration will be just described. Packet cluster. Okay, can you see the packet tracer?
Yes, sir.
Okay. It is our router. Take another router for ISP. For example, it is one, it is two. So first we just try to change the name. Just to maintain consistency. Okay. Just connect. Usually connect. ISP is connected. Okay. What we will do at first, we will assign IP address to the interface. This is and from ISR 431, your internal network is connected. Okay. We are demonstrating the static routing. How we can assign? It's very easy. Okay. Go to the CLI. No. Show IP interface brief. The similar commands you run in the switch also. Just config IP address as what is the what IP address I plan. Okay, I can copy also. Okay, that would be easier for me. Okay, interface 00. Copying this. Okay, no, at first
So you project to copy interface.
Interface, yes, you are right. ZI, then tab, you will get the name. Okay. We are assigning IP address to gigabit Ethernet 00, which is connected to ISP. Okay. Here we are assigning IP address. Look, 172.16.17.2. Subnet mask is /30. Why 30? It is point-to-point connect. Just use /30 a IP address in point-to-point case, because it will reduce the IP address was. Okay.
Does this support side annotation?
Command in the command.
Yes, sir.
Some routers support CIDR command, but in Cisco, what will be the command? I have checked. Okay, let me look. Okay. For example, here is question mark IP subnet mask. Oh,
It says
yeah.
/30.
No. If we just give /30 to another, no. Actually, in Cisco, we always give in decimal format. But for example, MikroTik router, you just give CIDR, and in Palo Alto also CIDR. Okay, it depends on case basis. In Cisco, I cannot remember. I always give the in this format. Okay.
Yes, sir.
Okay. Anyway, it depends on vendors. Okay. No short. You can use no short down command. Sometimes. Okay. Can you write the? Okay. Sometimes write command you can execute because when we execute this command, they are in the running configuration. If your router is rebooted, okay, or power loses power and it boots again, it will lose the running configuration. Okay, this is important. Sometimes you configure the router, but you have not saved by running write command. Or another command is copy running configuration to its ROM. Just it's what is that? Two types of configuration. This is running configuration. Another is, can you remember?
Startup configure.
Yes, startup configuration. Startup configuration is saved in your ROM, router's ROM. That is permanent. Okay, remember it. Because sometimes you configured everything, but mistakenly you fail to write in the ROM, and sometimes someone reboots it and you will not find the source command. Okay. Let's see the IP interface 3. Okay. And we have to configure other side. Okay. Let's copy this command. Here we have to. Okay. Here configuration. So at first you can check the interface name. So interface IP interface 3. Interface PI 00. Okay. IP address. So I have copied the command. So okay, link is off. Okay, so your so your link is off now. Okay, both sides you see green LEDs.
So ideal life scenario, we will always have to take a default route, right, for our home router, because we might not know the IP address of our ISP.
Yes, you are right. In almost always, we use default route to the ISP. Okay, default means whatever the traffic, it should go there. This is default. That is name is default route. Default route is actually static. Okay, but at in addition to your ISP, you have another office, for example, that is directly connected to your router. Not so the ISP. In that case, you will have to configure a static route to that link. Okay, to reach that network, you will specify a static route. Okay, that is why, of course. On the other hand, if you are seeing from the perspective of organization, you are talking about default route to the ISP. Imagine you are an ISP network engineer. What will you think the networking toward the organization?
Yes,
That
yes,
will
sir.
be, maybe you are not clear. When you are working in ISP, okay,
Yes, sir.
you have to configure the routing to an organization.
Yes,
Then
sir.
what will be the routing? Is it static routing or default routing?
So in that case, maybe we can allow PP only, or point-to-point protocol.
No. Point to point is not issue. Here issue is you will use static route to the organization.
So if we have multiple organization, in that case, it might not be feasible.
No, you will use different routing for separate routing for each organization.
Okay.
Okay. For example, one organization came to you. I need ISP connectivity. Okay, you will give the static routing to them. Then another one. In this way, you will. But if you are working within an organization and you are configuring routing to the ISP, that is default route. Okay,
Yes.
you should be clear here. Okay, for advanced routing, where we will show BGP, for example, border gateway routing, we will discuss later, or this is limited discussion in CCNA, although. Okay, we will show that. But generally, not generally, actually, in almost all cases, in a small or medium organization, it is default routing to the ISP. From ISP, it is static routing. Okay, it's clear?
Yes, sir.
Okay. And although this lab is quite different, this lab's main aim is to show the static routing. Here, why we are showing a static loop in ISP router? There are some networks. Okay, loopback, name loopback, 10.100.0.1, this kind of 3 networks, for example. Okay, these networks are known, so we will use those in a static route. Okay, why we use default routing? In case of internet, we don't know all the networks. There are millions of networks. Okay, and new networks are added. Some networks are removed. So everything is happening. So it is not possible to specify each network. Okay, that is why we just use we just go there. Okay, we'll discuss in default routing in today's discussion. Okay, briefly. Here, when you complete this lab, you will use all the route. I am just using one sample, loopback 0. Okay. Do you know about loopback?
Yes, sir.
Okay.
This is
Great.
for troubleshooting.
Okay, loopback. What we interface? It is a virtual interface within a router. Okay, it is used for several reasons. One, for management IP. For example, if you want to manage a router, you can use interface IP addresses for management of router. Okay, are you clear about route management? What is management? Management is for configuration and monitoring of router. In an organization, you have to you have so many routers in different places because for example, your office is here, but your routers are around, for example, 500 kilometers far away from your office. Okay, so how can you manage them? Through management network. Okay, you cannot go there instantly, so you have to configure remotely. That is management. So how we can access those router or switches from a distant place? We just connect using the interface IP addresses for routers. Okay. For example, in this router, we set 172.16.17.1. This is interface IP address. Okay. You can use SSH connection or web-based management. Okay, you can use. Also, you can use using loopback. Okay, loopback. Some people prefer to use loopback because loopback is not dependent on interface. Sometimes some interface may be down for some reason. Okay, loopback interface 0 is created given one IP address of 10.100.0.1. It is now normal interface. It is like normal interface. Okay. What's wrong? Oh, sorry. What are just IP address? IP address. Okay. Oh, sure. Okay, and look, show IP interface brief. You can see that our client IP. It is router IP. Okay, it is ISP's router. So our client's IP interface is gigabit 00, which is up. Okay, and another loopback 0, which we created, is also up. Okay, we will now configure static route in the client's router. Okay, client's router.
So, sir, what about the password? It is not secure. We create a loop.
Yes, no. Okay, today we are not talking about infrastructure security. We have a dedicated session on this, how you can protect your networking system. If you don't use password or other security mechanism, your network will be insecure, and any malicious actor can take control of your network, and they can do whatever they like. That is why security is important. We will discuss it in detail. Okay. Look, now we will give routing to the ISP router. Okay. What is the command? And IP route. Okay. Okay, let me copy that command. Okay, we created one loopback. One loopback means one one network. Okay, we will try to reach that one. Okay, just one route. You will configure all the routing. Okay, how you configure one route IP route, for example. The command format is IP route. Then the target network. Okay, what is your target network? Your target network is, look at this. I created loopback 0. Hello 0 10.100.0.1. It is interface specific IP address. But its network is side yard notation is 24. That is its network is 10.100.0.0, right? That is configured here, and IP address, network address is written, then subnet mask, then exit interface. Okay, what is exit interface?
Interface to which are connected.
Yes, let me show you how can. Okay, here exit interface is gigabit Ethernet 0/0/0. Okay. Okay. So we are talking router. What we are talking router? I want to reach 10.100.0.0 network, which has subnet mask of 255.255.255.0 and go through this router's exit interface. That means the interface that is connected to our target system. Okay. Okay. Now show IP routing table. Let me check routing table. So IP route. Okay. You can see the routing table. You have to develop your skill about reading the routing table. Routing table looks like this. At the top, there are some legends, and this is specific some symbols. Why some symbols are used? L means local, C means connected, S static, and so on. Okay, for different routing protocol, it has symbol. For example, REAP, we will discuss later. Okay, R. Today we got 3 symbols. S means static, because we use static routing. C means connected. L means local. So what is the difference between them? Look, 10.100.0.0. This network is obtained through a static route. Okay, this network is in router 2, right? But we get in this routing through our routing. Okay, I forgot to run this command before executing routing command. You got it blank. Okay, but as we run this command, IP routing command, it is an instruction to the router how you reach your target network. Okay, your target network here is 10.100.0.0. It is obtained from through a static routing, that is S appears here. Okay, and interface is gigabit Ethernet 0/0. That is you obtain this routing through gigabit Ethernet 0/0. Okay. And what about C and L? C means our point to point. In the figure, someone may thought that point to point is whatever. No, point to point is not. I just did this point to point IP connectivity. Okay, point to point IP. Point to point network was 172.16.17.0/30. So it is connected network. That is, it is C. Okay. So where it is connected? It is connected gigabit 00 interface is connected. Okay. What is local L? What is /32? Okay, we discussed. Yeah, all the four, all the bits of network is one. Actually, it represents host. Actually, it means no network. It is host. Actually, directly host. Okay. So look in the diagram. This router ISR 4331 itself a host. Okay, it has IP address 172.16.17.2. If it is the local IP address, it is represented as OL. That means this IP is used locally. This IP address is used locally. Just remember the languages, then it will be clear to you. So are you clear about three terms: static, connected, and local?
So can you repeat the connected? Which IP address?
No, it is network. It is not IP address. It is a network. Okay. So we use in point-to-point network. Look in the diagram. In the diagram, used to point-to-point IP 172.16.17.1 in one side, .2 and another side. But what is the network? Network is 172.16.17.0/30, right?
Yes, sir.
It is the network. Why use 30? To reduce the IP address wastage. We use /30. That is, this network is connected network. Okay, this is how you understand the routing table. Okay, so we have another 2 or 3 labs that are similar with the same topology, but that I can explain or changing this. Look at this. Okay, one thing. Remember, routing table. Okay, I'm just copying this routing table. Oh, don't need it to be here. I'm changing a bit. Okay. The name of the lab is static routing via exit interface. Okay, what is this? Look at the command. Just repeat. Our command was IP route. Then our target network. Then at last we give gigabit Ethernet 0/0/0. That means we instructed our router that go through our exit interface. Okay. We could give this. Okay. Now let me remove the this command. We will delete the. Just put no before your command in Cisco. Okay. Now it is. Now check. So IP route. What is this? Okay, you can see that 10.10, sorry, 10.100.0.0/24 network is not present in this routing table because static routing is removed. Okay, you can only see connected and local. Because there is no static routing. So we will use a slightly different command. This. Now, router 1. Okay. Okay, look at the command. Can you see the command?
Yes, sir.
Okay. IP route our target network 10.100.0.0.255.255.255.0. Then we put in an IP address which is next hop IP address. Look in the diagram. In the diagram, you are on user router. You want to reach some network in the connected to the ISP or foreign router. You just instructed in user's router that go to that router through the next hop. Next hop means our ISP interface IP address. Okay. We just put here and execute the command. Okay. So now show IP route. Now you can see static routing again. 10.100.0.0/24 is via 172.16.17.1. But in our earlier routing table, what was the scenario? There was this connected via this link. Okay. So what I am trying to make you understand that we can give command in two ways, static routing command in two ways. One is using exit interface, one is using next hop IP address. Then what is the difference between two? There are slight differences. For example, if we say that exit interface, then if IP addresses of the interfaces are changed for some reason, it will not be compared, and you don't need to configure static route again. So this is the one benefit. Are you clear?
Yes, sir. So in static, in the first one through the exit interface, even if the ISP router changes its IP address, we can still reach it, right?
Yeah. If you for some reason point-to-point IP address is changed,
Yes.
that will not hamper your static route. If you specify the IP address of next hop and next hop IP address is changed, then you have to change your IP route command. This is the difference. Okay. Okay. So
the IP address one came with the number of hosts that we need to travel. This one it also has some benefit.
Yeah. So this is one way. In two ways we can our labs, two labs aim to do this. Let's go to another lab. Another lab is default route. Okay. same scenario. So you don't think about this. What is default? Default. Default. Okay. Default route command is okay. One interesting thing you will see but in Cisco we don't use this. But in most routers, for example, MikroTik is commonly used or other routers, Palo Alto, for example. Look, you will see like this 0 dot 0 dot 0 slash 0. Okay, it is an important thing. Okay, it is important for default route. Actually, it means that all the routes that is not specified go through this. Okay. 0.0.0 slash 0 means any network. If you want to reach anywhere, if not specified, it is important. If not specified means if you specify a network here. For example, if you mention a network 10.12.7.0 slash 27. Okay. If you mention a network 10.12.7.0 slash 27 and it will it will go through this as this route is specified to a specific route. So if there is nothing specified, then follow 0.0.0 slash 0. Okay, it's clear about static routing and default routing?
Yes, sir.
It is very important. Some people think that if you give default route, then everything will go to the default route. Then what will happen to a specific route? No. For example, if you have a router, you put the default route, but you have another route to your another section or another small office. You have which has a special connection, not through internet. So you will just mention a specific route to this. Then if someone try to reach that network, that network will go through the specific route. And other routes, you want to reach YouTube, and then just go through this. Okay. Remember, it is very important.
So, sir, we can configure both of them at the same time.
Yeah, in a routing table, you can have multiple routing. In practice, you have so many routing entries in a medium to large organization, but in a very small organization, the routing table may be simpler. Look what we have. Okay, now we try with default route. Default route means Cisco look the command. Command means IP route is similar to static. Then 0.0.0, then a space dot 0.0.0.0. This means that any network, any subnet mask, any network not specified in the routing should go through this. Okay, go through this means this next of IP address. Here you can also use exit interface. Okay, we'll show this. Okay. Now here we will remove. Okay, look. So IP interface break. Okay. So IP route. Okay. Look. So IP route. Sorry. So IP route, you can see, but I want to remove the command. Okay. So run. We are getting running command, which will look in the router. It is class here, right? Okay, we will remove this command, right? Copy. No. No, not copy. Let me copy the. Oh, not copying somehow. Okay, let me write. Figure out. It is 10.100.0.0 to filter to .0. Okay. Okay. So I see route. Okay. So 10.100.0.0 disappeared, right? Now we will put, we will give the command of static route. Okay. What is this IP route? That is static route 0 any network through the next IP address of our IP interface IP of Isp router. Okay. Okay. Now show IP route. Now check IP route. Okay. See, S starring. Okay. You know, C means connected, and L means local IP address. C means connected, that is point-to-point network. And S is, what is S? S means, S static means default route. S means static route. Okay. S static, what I told about 0.0.0.0/0 is very important thing in routing. Okay. Via next of IP address. So we got through this. So can we ping how can we ping the IP address of loopback? Loop 0.1. Okay. Okay, we can ping, that is, this is reachable. So can you understand the these commands or differences?
Yes, sir.
Okay. Okay, last an interesting lab I have created for you is floating static routes is very important and interesting. That it is known as floating static routes. We'll configure. What is this? You have an organization where you have a one router, okay, R1. But you notice that your ISP, this connection sometimes is interrupted for different reasons, and you lose internet connectivity and you go offline. So this is a problem. So you decided that you will connect to other ISP also, so that you have redundant links. And if one link is down, and another link will serve you. Okay. Then how can you configure this? You will do it yourself because here the static route is used. Because the static route we discussed now, right now. Then how we can configure? From your router R1, you will just configure default route to R2. Is one ISP router. It is R3 is another ISP router. And you know, you have heard about administrative distance in routing. Administrative distance represents the importance of a routing in a routing table. If you have 2 or 3 routing, how can router choose one route? For example, in a routing table, you have RIP routing. If you have BGP, if you have a static, which one will take precedence? It depends on administrative distance. You know that the table of administrative distance in different source. So administrative distance, the lower it is, the higher priority. Okay. For example, one is more important than 100, for example. Okay. So you will use administrative. How it is? You will put all the interface IP address according to this diagram. But look at these 2 commands, which are important. From R1, R1 means your organization's router, where you are working. You have to, you have a default route to 10.2 is one next of IP address to ISP 1, and 192.168.20.2. This IP address is next of IP address of another ISP router interface. Okay. So we can put two default route towards 2 ISPs, but there are some difference. One has administrative distance, which is known as AD. Administrative distance is 254. That is, it will take less precedence, higher precedence, and default. What will be the default administrative distance of the static route? Okay, I could say, look, administrative distance a list, you will get a list here. Okay. For a static route, it is 1. For a connected, 0. Can you see? Or you?
Yes, sir.
Yes, sir.
Okay. In different books, you will also get it, but like it is available. There are different administrative difference distance. Okay, for a static, 1 default. If you don't mention, we get where is my lab? Oh, sorry. Okay, here. I didn't mention any administrative distance in first command. That means it has 1 by default. And second command, we mentioned 250. You can put any value higher than 1. I just try 254 here. That is, it will take less important. So in this way, you can use your one ISP connectivity as primary and another you will specify as secondary. That is, primary is always taking traffic, carrying traffic, and secondary one is just standby. When your primary fails, secondary will take the responsibility of carrying traffic. Okay. Or you can manipulate, we can say you can make secondary as primary by changing administrative distance. So it is very
So what is the
important.
maximum assigned value of the
Sorry?
administrative distance? What is the maximum assigned value of the administrative distance? Maximum assigned number. Like you say, we can put any number greater than 1. So what is the maximum value that we can assign? Is it 255?
No, you can change. If you change the primary as administrative distance, which is higher than secondary, and then that will be the primary link.
I mean the maximum value that we can assign.
Oh, maximum value. Oh, maximum value. There is it may be 255 as the maximum value. 255. Yes, it is 255 is the maximum value. If you cannot use 255 because if you use 255, it is known as unknown. Okay. For example, you use 1 to 10 value, for example. Okay. That is just make difference between them. Okay. Discriminate between them. Just. Okay. It is up to you. But range is here. Okay. As a network engineer, you always keep this in your at your disposal so that you can read them. Okay. So do it yourself and let me know if there is any problem. And these are very practical and you have to always clear about these concepts and hope you will do that. And next session, hopefully we will discuss dynamic routing or different other route IP addressing like super netting, for example, or route summarization, netting. Okay, this kind of concepts will be discussed in next session. Okay, do you have any questions or any clarification?
So can you share today's labs? Okay, labs 5.
Okay, sharing. Good. one. Okay, I am sending another one. IP floating. Sorry, did I share floating IP or this? Okay, let's share again. Default route. Default route, floating route is shared. I think the thing. Static with the next up. Okay, I am.
Share this floating static route.
Okay. Yeah, I already shared. Look. Okay. Got all how many left? Let me check. One, 2, 3, 4, 5 levels. Okay. If you get
PowerPoint slide.
Is remaining.
actually, I prepared.
Yeah, maybe you don't share this floating static route.
Yes, sir.
Why? Floating is not shared. Okay. Sharing again. Okay. No problem. Floating. Okay. Got it?
Yes, sir.
Okay. Do it yourself. I think these are very easy, but very important for real life activities. Although this is not developed properly. Okay, I'm sharing, however. Just you'll get one to slide. Actually, I think most of the concepts are familiar to you. Okay. Okay. We'll mostly focus on dynamic routing and related IP addressing concepts also in the next session. And if you have any question, you can ask, or we can close today's session. So since that you have no question, okay, practice all this yourself. Okay, I just showed you and practice all the labs today. Okay, that will be helpful for your knowledge development. Okay, thank you. Practice
Thank you
yourself.
very much, sir.
Okay.
Sir,
Yes.
sir, the first class I didn't attend it.
Oh, you didn't attend it.
Yeah, because I was in the hospital. I was not here available.
Oh, okay. You can collect all the material from your peers, or I can also share. And how can you recover? You can go through all the materials at first. Okay.
Sir, I have them, all of the materials, but I wanted
Okay.
that to get
Okay.
attendance. And I understand all of them.
Okay, great. Still, if you have some questions or anything you want to discuss, you can ask me. Okay, or you can note down yourself just which areas you should discuss. And in that case, in the next session, in the beginning, you can ask me. Then briefly, I will discuss. If I need further discussion, then
Sir, there was some problems, and I discussed them with some of my team, my classmates.
Okay. Now it's clear to you, or
yeah, it's clear. Everything is clear, sir.
Okay, great. Okay.
Only the first class. Then all the classes I attend them.
Actually, past class, in the past class, there was just basic discussion. Later, I found that you know the basics. So I tried to focus on labs. Actually, if you practice the labs, and your theoretical knowledge will be stronger, or more clear. Okay. Thank you.
Okay, thank you, sir.